Mohinee Singh and I'm from Cyberfrat team. So today we are going to talk about the threat landscape in manufacturing environment in Industry 4.0. So without taking much time, I would like to introduce you all with our guest speaker, Mr. Apurva Dalal, who is going to enlighten us with his knowledge and experience with us on this particular topic. Mr. Apurva Dalal is an innovative senior IT leader with 28 years of experience. He is committed to keeping up to date on modern IT systems and planning technology strategies to align with company goals. He also analyzes current and evolving market trends to develop long-term solutions. So welcome, sir. It's a pleasure to have you here.
Thank you, Mohinee. Good morning, everyone. So let me start with the topic today, threats of manufacturing environment in the era of Industry 4.0. So before I jump directly to Industry 4.0, let me give you the background of what are the things that I am going to cover. Because to reach Industry 4.0 and the threat landscape and the attack surface on the Industry 4.0, so I'll just briefly go through IT and OT, what are the priorities, how Industry 4.0 has arrived, what it covers, what is the importance, and what is the role of our operational technology within Industry 4.0. And I'll briefly take a couple of case studies and then we can have a question and answer. So just to give you on IT and OT integration. So basically in today's scenario, earlier days, IT used to work separately, OT used to work separately, but in today's scenario, it cannot work separately. It has to be integrated. So if you look at the landscape of IT, so it's like our standard IT systems like laptop, desktop, servers, applications, and all that. And then the IoT came into picture where we had smartphones, smart locks, smoke alarms, and all those things. On the OT side, so these are mainly for the manufacturing industries where, these are all industrial control system where it is all programmable logic controllers, SCADA system, physical plant equipment. So if you are having a manufacturing industry, there are a lot of physical plants equipment over there. Or if it is a ports and logistics, you have cranes and everything. Industrial network. So within the plant, you have the network. So that is the part of industrial network. And when we talk about industrial IoTs, then we talk about sensors, embedded system, and all that. So this is how we are integrating today IT and OT systems. So if you look at what are the priorities, so in IT world we always say CIA is the priority: confidentiality, integrity, and availability. But in OT world it is different. Safety is the highest priority. The reason behind is because this is all physical equipment. So if anything goes wrong with this physical equipment, then the safety of a human being is affected. Okay, so if anything goes wrong in a plant, it will affect the human who are working on the plant. So that's where, if you see, the priority changes. It is safety, integrity in terms of the configuration of the equipment. So if there is any misconfiguration, again it will impact the safety. Availability is lower priority, and confidentiality is the lowest one, because these are physical plants. So confidentiality is there, but eventually it is not it does not matter as much as in the IT world. So that's how the priority are differing between IT and OT. So towards Industry 4.0, so when you merge IT and OT, Okay, so it is not only IT and OT, there are a lot more things that will be part of Industry 4.0. So if you look at IT side, you have network, servers, cloud, endpoint, everything. On the OT side, you have PLCs, RTU, HMI, machinery, embedded technologies, and all those things. So once we merge all those things and we add few more things, then we come to Industry 4.0. So where autonomous robots are there, system integration, Internet of Things, additive manufacturing, cloud computing, augmented reality, big data in terms of, because all the sensors and everything will generate a lot of data. And all this requires a security. Hence, the cyber security is also important point in Industry 4.0. So what is Industry 4.0? So as I showed you the diagram, okay, it is a combination of IT, OT, and Internet of Things. Um, Basically, you can say it's a smart factory where everything is handled with sensors, embedded systems, and all that. So that's how the Industry 4.0. The network of the machines are digitally connected. So you can do predictive analysis, predictive maintenance, and all that. You can share the information uh, real time. So that is how it works. So I'll talk about how the digital twin and CPS works in Industry 4.0 also. Internet of Things and the cloud, these are key components because it generates a lot of data, and this data keeping inside the environment, you need elasticity, which is not feasible, and that's where cloud plays a bigger role, because the amount of data being generated by Internet of Things is huge. It's in terabytes and petabytes. So if you look at connected cars or smart factories, uh, each and every sensor generating data every second is huge, and hence you cannot have this data available within your data center. Definitely the cloud is the option for that, to have the data lake, you can say. That's today's terminology, where you have petabyte or terabytes of data and do the analysis. Some of the trends is smart factory, what I spoke about, modular structure, cyber physical system monitoring processes, and all that within Industry 4.0. So if you look at how it started, so first it was just a mechanical production. So we had like steam engines or water treatment plants and all that. Then it moved to mass production, where we had cars being produced within the production lines and all that. Then came the electronic and IT automation, which played a major role into the industry. And finally, today, it's the Industry 4.0, where we talk about cyber physical systems, where physical systems are in real time talking to IT systems, generating analytics, giving back the feedback to the physical systems, and that's how they operate. So that's Industry 4.0. So, what is the importance of cyber physical system and digital twin for Industry 4.0? So, when you talk about cyber physical system, it is nothing but integration of networking and the physical processes. So, you are having your SCADA machines, or you are CNC machines, which are connected with the networking systems, which are giving data back to IT systems. Those IT systems will do a lot of analytics on that, and it will give feedback to the physical system, which will allow you to control the physical processes. So if you look at the diagram below, where I'm talking about physical assets, and then we create a digital twin. So this is the simulation which is done within the IT system, where all the data generated by the physical system is fed into the data analysis is being done, and again the decision has to be taken by the physical system. So that feedback is again given back to the physical system by the digital twin. And that's how the CPS and DT both work hand in hand and gives the best output. In contrast to IoT, common parallels is generally limited to physical assets only. So they are not the digital model. IoT is not a digital model as such. Here, whatever your physical assets, it tries to replicate into the digital world and gives back the feedback to the physical system, and then physical system controls their processes accordingly. So that's how the today's industry 4.0 will work with cyber physical system and digital twin. Now the major part within industry 4.0 is the industrial control system. So if you look at the OT is the outer circle, which is called operational technology. It is nothing but the computing system that are used to manage the entire industrial operation. Within that, you have industrial control system, and then you have your PLCs and discrete process control system and the SCADA system. So if you want to control your industry 4.0, okay, how it is IT and OT relates to eventually get you to industry 4.0. The SCADA system is mainly the systems which will give you a lot of remote monitoring, control and monitoring of your physical system. So if you look at a power plant where you have set up a huge thermal power, or ports and logistics where you have your cranes operating using the SCADA machines, okay, you monitor it online. Or you look at a thermal power plant where you can look at the power generation happening online, whether the centrifuge is working correctly, turbines are working correctly or not, inverters are working correctly or not, or what are the configuration changes online you have to make so that power systems are generating power optimally and it is not impacting the systems or doing any misbehavior. So that's where the industrial control system plays a major role in industry 4.0. If I'm going too fast, let me know. So what are the ICS and SCADA protocols? So generally when you use the SCADA system, in IT side, we always talk about TCP protocols, we always talk about UDP protocols and all that. On the SCADA industrial control system side, there are different protocols which are being used. So if you look at it's a DNP, IEC, OPC, the major protocol which is used is a Modbus protocol in the SCADA system. Okay, so this protocol is not that as secure as other protocols, but this is what majorly used within the SCADA system. And I'll talk about why this Modbus protocol is not as secure as other protocols. So when I talk about that you need to, for industry 4.0, you need to protect your industrial control system a lot. Why? Because these devices are utilizing insecure communication protocol. So when I talk about Modbus protocol, there are no authentication in this protocol. So whatever data is going back and forth, it is in clear text. So if you are a threat hunter, or if you are a ethical hacker, and if you want to look at what is happening within the SCADA system, you can use tools where you can look into the Modbus protocol and you can find out what is going in and coming out from the devices. So hence, lot of things need to be done to defend the ICS system. Hardware and firmware, like if you look at the SCADA systems, when it started early, they used to come with embedded cards. Okay, these embedded cards were like either the Windows CE in olden days, and then it came out with Windows XP, then Windows 7. Today also, there are very few SCADA systems which have Windows 10 availability. So hence, and the lifespan of the SCADA system is around 25 years. So like if you have just put your plant 10 years back, you know, it might be still running on a Windows CE or Windows XP. Now, if you want to upgrade this firmware, it is very expensive. I have experienced this in my real life. When we had a system which was like around 15 years old, and it was running Windows CE embedded system. So when we were looking at the threat landscape and said, oh no, we have to upgrade it. But the cost of upgrading was going into crores, and it is not single digit, into double digit. So, that's where the question comes from the business, whether to upgrade it or to buy it. And you have to justify the ROI, because the systems are not cheap. They don't come in lakhs or and these are all very costly system. And when you want to replace the system, the amount of downtime you require, it will affect your production and all that. So all those things need to be planned. So hence, to the firmware that might have challenges because it is using the older system, or it may have the hard coded backdoors, because OEM wanted connectivity to ensure that systems are running fine. They want to monitor the system remotely and all that. But the attacker can take the advantage of this backdoors, because today if you look at all this SCADA system, you will find the vulnerabilities available over the net, and definitely you can take advantage of that. So that is one of the thing that you need to defend ICS system. And same thing applies to their softwares also. So a lot of SCADA system will come with monitoring software and all that. So if you don't keep that updated, then again there is a chance that your system is vulnerable. So how your SCADA gets compromised? One of the major thing today, we are integrating IT and OT. Okay, but because business pressure or a lot of things, we do not segregate the network between IT and OT. So this is a major challenges that is faced in compromising of your SCADA system. What happens is, if you don't have VLAN segregation of your IT and OT, something goes wrong in your IT network, it will spread to your OT network. So that's the major challenge of weak segregation. Hence, you have to have a better segregation between your IT and OT. Otherwise, it will allow malware attacks on your IT system, which will spread to your OT system. The other thing I already spoke about, weakness in ICS protocol. So the Modbus protocol uses clear text communication. So, and it is kind of a man in the middle attack can happen. So attacker will eavesdrop on your traffic. They can look into it, what is happening into your system, and which may lead to unauthorized access, and then updating of your system. So they can they can take control of the system. They can make configuration changes. They can shut down the system. They can slower down the system. They can do all the things what an administrator can do, SCADA administrator can do. So that's the weakest part in the ICS. Then there are default configuration. So as IT guys, I'll tell you, sometimes to get the systems up and running, we just go ahead with whatever default configuration has come with a OEM. We do not try to look into configuration. We do not look into the patches that is required. So we just go ahead and say, okay, just switch on, power on, click next, 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 system is up and running. So the simple example I'll give you on the IT side. Suppose you are buying a Cisco router or Cisco switch. You know, the default user ID and password is always Cisco. So sometimes, you know, people just want to get up and running within minutes. They will not look at all those things. They will not change any password. They will not look at what are the ports to be closed and all that. They will say next, next, next. Okay, my router is configured, my switch is configured, I am up and running. So these are the things which will create a havoc. So if you don't do this, then there will be a loss in production, loss in revenue. And the biggest thing is the brand image. It will also create a brand image issue. Then finally on the application side. So there is a human machine interface application with SCADA system. So if you are using a web-based HMI, always need to look at it whether the systems are updated correctly or not. Parameter manipulations are not available, or you cannot do any SQL. So you have to do normal kind of application penetration testing. Then only you put the system in live into production, because you know, we have an idea. Okay, OEM has developed, so this must be secured. Let us do implement it, run it, and we are safe. But these are not the case, because you know, applications are not the only issues. Operating systems are also the issues. Hardware also are the issues. Because of the hardware or the firmware or the drivers which have the backdoors or the vulnerabilities, it may impact your applications also. So you have to look into this applications, ICS applications also, like any other IT applications. You look at and do the application penetration testing, and then only release for the production. So this is, I have just given some few critical high level things how SCADA gets compromised. There are a lot more points where you know that there can be a compromise on the SCADA system. Now, what is the attack surface that you have on the SCADA? So it is like you are dealing with a combination of vulnerability, system configuration, or the system features like I spoke about. Okay, you are trying to implement the HMI solution, and if you have not done changes to the default configuration, then it's an issue. That's the attack surface. Your hardware, your historian, your remote control unit, PLCs, all these are the systems which can be attacked if you do not have proper configuration done, or you have not applied the latest firmware patches or the software patches. Then there are backdoor communication. So OEM will always have something to look into their systems. So when you implement such system, you need to speak to OEMs, and if they say, yeah, there are the things available where they need to control, then you have to see how do you protect them, because this backdoors can be used by attacker to attack your system. So one of the reason, you know, what we do is to provide OEM to do remote patch management or do any configuration changes. We expose our SCADA system onto internet, which is not the right way to do it. So because that is again a challenge, you know, because if somebody is watching, then they can just tag along and they can take control of your SCADA system. So that's on the, then again, the network. If you want to bridge your IT and OT network, so I already spoke about is you have to have a segregation of your network. So you, if not physical, you have at least a virtual segregation where your IT and OT network is separate. You don't have your internal substation network directly connected with your Wi-Fi network also, because the internal substation network is very critical. Then there are connections to your SCADA through workstations. So you have to harden your workstations, because again, these workstations are nothing but a Windows desktops or laptops. Okay, so if you don't put the patches correctly, it will again impact your system. uh, you have to shut down all the unneeded ports. So what you do when you do for your IT systems, you have to do similar things on your OT side also. That when you are implementing your SCADA, look at what are the ports which are not required and shut down those ports, shut down those services, because again those are the uh, attack surfaces for them. And I spoke about HMI in my previous slide, so I'm not going to repeat that. But HMIs are also be to looked at very seriously before moving it to production. So, what are the attack modes on the SCADA? One of the biggest challenges when somebody attacks, you can have a loss of view. So if your somebody has taken over your SCADA, and you will not have a view of what is happening to your industrial control system because your HMI is compromised. Or a person can manipulate your view. That will say, okay, everything is running fine, and behind the scene they will move your they will shut down the centrifuge. They can do that. Or they will flood with the network attack, so that will not have control over your HMI or over your SCADA system. It's a denial of control. Eventually you will lose the control. So they can completely take over the system, they can throw you out of the system, and you will not have the control. So that is the loss of control. These are the different attack modes they will use. Some people may just say, okay, I will not allow you to view, or I will allow you to view things that I want you to view, but behind the scenes I can do whatever I want to do. Or I will manipulate the controls. Instead of running centrifuge at certain speed, I will increase the speed or I'll decrease the speed, and that will impact your system. So these are the attack modes of ICS. Now, what are the threat landscape? So as I already spoke about that, whatever endpoints that we use for the system, they are still the Windows based system. So whether my SCADA system, I might have Windows C, Windows XP, or Windows 7. My endpoints which are connecting to the SCADA, they are also Windows based system. So these are the systems which I can exploit. So hence, we need to ensure that we keep the system updated. There are so I have given a link over here. The tool that you can use for recon purpose is Metasploit again. So if you have been using Kali Linux, you must be aware about Metasploit. Okay, so Metasploit is one of the tool which you can use for recon purpose for SCADA system. Now you can use these tools in your favorable condition also, or attacker will use for his or her favorable conditions. Another tools, I would say it's like Agora SCADA Plus exploit tool. So I've given the link. What it does is it attempts to collect all the publicly available SCADA vulnerability. Okay, so there are sites, CV sites and all that, where by OEM, they have put what are the vulnerabilities in the SCADA system for what firmware, for what version, and all those things. So these are available. So this tool, what it does, it will collect all this, and then it will try to exploit this based on the type of the system that you have. And finally, you have the exploit DB, where you can go and search what are the exploits available for a particular. So if you are using for a Siemens or for Suzlon or whatever for ABB SCADA systems. You can go and find out, okay, for this model number, these are the vulnerabilities available, and this is how I can exploit it. So how do I fix it? And then on the internet, a lot of tools are out there which are available. So if you go to shodan.io or census.io and you type a model number of a SCADA system, and it will show you all the vulnerabilities available, or what are the systems which are online, you can pick into it or not, all those things. So these tools are, kind of a double-edged sword. Why I am saying that? Because, as a CISO, you will use it for the right purpose to defend your system, but attacker will use for the malicious purpose. So, and I have not listed, there is a laundry list available, but these are the few important things that are that you can use to defend your system. Hence, I have listed this over here. There are a lot more available. So if you look at the documents available on the NIST also, they have given the complete how to manage the SCADA system. In US, Department of Homeland has also a document released in September 2016. I have not yet seen the updated document where they talk about the entire SCADA system, threat landscape, how to secure it. All those things are available in that document. So how do you defend your SCADA? Okay. So why I am talking more about SCADA, because Industrial 4.0, eventually the manufacturing systems are all about industrial control system. Hence, I am talking more about this. So when you want to defend your SCADA, please separate your IT and OT network. You have to have a separate network segmentation. Block and shut down all the unneeded unused ports on your firewall. So there are multiple ways you can connect your SCADA, because I have seen people, when they connect IT and OT, they do not put any firewall in between. They just put one switch and they connect IT and OT. So that is not a right approach. I would suggest you can use a firewall. Nowadays, there are firewalls which are capable of working as a router, as a switch, and firewall all in one. So if you don't want to spend such kind of money to buy all three individual asset, you can buy such a firewall available for specifically for ICS I'm talking about. And you can implement one box which will give you control, which will act as your switch, which will act as your router, which will act as your firewall also. Shut down all the services which are not needed. So please ensure that you shut down your services. I spoke about the HMI software. So you can always go and ask OEMs, can you give me MD5 hashes for the software? If you have the MD5 hashes, you validate it and you find out whether your software is compromised or not. If vendor has not provided, you need to create one and then ensure that it is always matching with the hash you have created. So that is the most important point. Please remember on the software side of it. Then deploy endpoint protection to IoT and other devices to establish visibility of the threat. If possible, I don't know whether every organization will invest or not, but then you should have identity and access management policy to control. So if you don't have the system available, you might have to do it manually, but you need to have this identity and access management policy in place, because you do not want outsider to get access to your network and prevent employees from accessing the system. So that's where it is important to have identity and access management policy in place. Access control policies. So even in the SCADA system, you apply the policies. who are the people who can do configuration changes, who will do only the monitoring part, all those things. System hardening, I spoke about. IDS, if you can implement IDS, some of the firewall have built-in IDS, you can utilize those. And finally, the periodic assessment and audit of your OT system. Just like what you do for your IT system, you should do it for your OT system also. So this is just a depiction. It will differ from organization to organization, but generally these guidelines are given in the Purdue model also, that how you should have a secure network architecture for your SCADA system. So if you look at, you have a DMZ zone where you have your web server, email server. This is your IT part of it. You have domain controller and business servers and all that. Then you come to your control center where you will have your historian, you will have remote access jump server and all that, which is your DMZ part of it. Finally, you come to your manufacturing zone. When you come to your manufacturing zone, you have HMI, you have your IO server, you have your historian and all those things. And then eventually onto your SCADA DCS, where there is a separate LAN for your HMI, separate LAN for your field controllers, separate LAN for your sensors and all that. So this is a recommended architecture. It may or may not be possible in all the scenarios, but this is how, if you segregate your layers, then you can take a lot of control of your system and protect your ICS system. So what are the common challenges generally faced? So we have looked at all these things. So we have IT network threats, so we have OT network threats, we have misconfiguration, malware attacks and all that. So there are different components we have. So if you look at in manufacturing side, we generally now a lot of companies today have adapted to RFID or barcodes or intelligent sensors, because when I talk about GPS and all those things, why it is because if you are look at solar plant or in general, it runs into kilometers and kilometers. So humanly, it is not possible to walk around so many kilometers and look at all the assets deployed and all that. So that's where, this RFID tags or intelligent sensors are deployed, so that you can remotely monitor them and look at your assets. But, because of these things, you have a threat. Okay, why? Because somebody can do unauthorized access, somebody can put a malicious code to attack it, and hence you need to protect that layer. Then it comes to your network layer, where you have VLAN, you have cloud network, you have wireless sensors and all that. So again, there are security threats where you can have DOS attack, you have a transmission thread, or you can have a network congestion, data breach and all that. Then comes the service management layer, where the APIs are being deployed and all that. You can have attacks, different attacks over that. And finally, your application layer, where you are using smart applications like HMI and all that to monitor. So again, the misconfiguration will create an issue, or malicious code can create an issue. Phishing attack will create an issue. And I'll talk about in case study how these things have happened, uh, where malicious code has been deployed or a phishing attack has been done, and it has compromised the OT systems. So, how do business leaders in the manufacturing industry should work with the team, to ensure that we secure the SCADA system? So when we are talking about, as a CIO, if I go to my business team, and I say, okay, I need to deploy ideas, I need to deploy, do this, that, all those things. They will always say, you are IT guys, you are always talk about spending money and all that. So we have to deal with them in a different way to ensure that we get the system secured. And there are ways to deal with the business leaders, because business leaders, you can't talk technically. You have to talk in terms of the ROI. You have to talk in terms of loss of revenue and all those things. Then only they will understand. So uh, in the manufacturing industry, what we expect for a business leader to do is using, they have to have a cyber security in place and integrate different technology to have faster access. Okay, move towards zero trust. So now this is the new thing that has come into picture, zero trust architecture. So even though you are an authorized user, your the asset that you are using for the organization is also authorized. But every time you log into the system, you log in as if you are a new user. So zero trusters will always check, are you authorized user? The asset that you are using has been authorized or not. The applications which you are using has been authorized or not. So that is the zero trust architecture that people are moving towards in today's supply chain scenario. Leverage the automation, artificial intelligence, machine learning to ensure the intelligence infused at every level of manufacturing process. So when I spoke about the CPS and digital twin, okay, so digital twin is nothing but it will take all the sensors data, do all the analytics, all machine learning will be applied, and then it will give feedback back to the CPS system, so that CPS system can give the feedback to the actual physical system to control the process. So cybersecurity has to be the highest priority in the organization, where it is not just the IT part of it, but for the OT part also as of today, because OT is our critical infrastructure. If you look at all these power plants, nuclear plants, or the water treatment plants, they are all run by this industrial control system, and these are all critical infrastructure for the organization as well as for the nation. So there are national critical infrastructure also that comes into play. So I'll just go through a case study. So this is like a Stuxnet. It's a malicious worm which was uncovered in 2010, though it has been in development since 2005. So what has happened? So this is the nuclear plant which got impacted in Iran. Somebody sent out, did a phishing attack. Okay, they sent out a malicious code in Microsoft Word. Okay, so the memory stick was infected. Somebody gave an infected memory stick. So it impacted the endpoint of the system in the IT side of it. I'm not talking about right now OT. So it impacted the USB stick which was infected. It impacted the endpoint. It deployed the worm within the system, and then it remained in the system till it got the access to the privilege access. Okay, so once the privilege access was given, what it did, it compromised the 0-day vulnerability of the controller. Once it got the access to the controller, it what I spoke about, what are the kind of a loss of vision, or I can show you what you have to see, right, but behind the scene I will make the changes what I want to do. So it is deceive and destroy. Okay, so maybe on the monitoring side they always said, okay, centrifuge is running fine or the controller is running fine, whereas in background it increased the frequency of the centrifuge. Eventually, what happened? It crashed the entire system. So once it crashed the centrifuge, the whole system got shut down. So this was man in the middle attack between the engineering workstation and the PLC. PLC is nothing but a programmable logic controller, which is running the logic for your SCADA system. So that's how the Stuxnet, and there are multiple versions of Stuxnet that came out after that. But this was a major attack on the nuclear program, which had happened. The second, which I will talk about, was black energy. So what is black energy? So it was a Trojan. It is used to conduct DDoS attack and all that. Again in 2014, it impacted Ukrainian power grid. Okay, and not one. It impacted 3 energy distribution company. Somebody did a spear phishing attack, sent out a Microsoft Office document that had a malware in it. So there was a code which was built into the Microsoft Word document. Somebody opened the document and it released the attack onto the system. So it attacked the SCADA system. People lost the control of the SCADA system, and then eventually attacker took over the advantage, and it's what it did. It blinded the whole HMI part. Okay, so when I am doing a monitoring of my power distribution, if I don't see how much power is being generated or whether my substation is working correctly or not, the whole thing was blinded. I had loss of vision, and eventually it shut down the substations. So it had a major power grid issue and power loss to the end user. So substations were switched off, and this happened to 3 energy distribution company within the Ukraine. So that's how the spear phishing. So that's where when we talk about that, you know, why IT and OT has to be integrated, but what are the things that we need to take care of? These are the things that we need to take care of. That, you know, if you are reading your mails, you are opening the attachment, but if you don't know from whom, whether the person who is sending, you know that person, and then only you open the attachment. Otherwise, those kind of things will happen. The attacker will take the advantage and it will destroy your substation. So these are just 2 case study that there are many case studies available. So, but these were the 2 major case studies. One was on nuclear power plant, one was on substation. Recently also you have heard in past few months back, the ICS system getting compromised. And what are the reasons? These are the backdoors, or the maybe the HMIs are not correctly configured and all that. So that's it from my side.